Hello friends, speed is one of the most important characteristics of traffic and its measurement is very frequently needed in all traffic engineering studies. And therefore, today we will discuss what are different types of traffic speeds and how these are measured. The speed, as you know, is the rate of movement of vehicles, that is the distance traveled in 1 hour. It is generally represented in kilometer per hour or miles per hour, or in case of pedestrians, it is in meter per second also. And there are several types of speeds which are used in traffic engineering: spot speed or instantaneous speed, time mean speed, space mean speed, running speed, journey speed, and there are many more which I will discuss in the end of the presentation. Spot speed, or also called instantaneous speed, is the speed at a specified location on the road, and therefore it varies with location. Now it can be measured at a spot or in a short length of the track or section of the highway. The applications of spot speed data are in geometric design of roads, for regulation and control of traffic operations, for analyzing the cause of accidents, and also it is used in before and after studies of road improvement plans. The second type of speed which is used in traffic engineering is time mean speed. Now time mean speed is also measured at a particular location, a particular point, and this is the arithmetic mean of spot speed data. And therefore, if you measure speed at a particular reference point, then take the average of all these speed, that is the time mean speed. Say for example, if you consider three vehicles on a road and you measure their speeds, spot speed at this reference line, 60 kilometer, 80 kilometer and 50 kilometer per hour, then average of these three speed, that is 63.33 kilometer per hour, will be the time mean speed. So as I told you, it is the arithmetic mean of individual spot speed data. And because it is the mean of spot speed data, and therefore uses of TMS or time mean speed are same as of spot speed data, that is to establish speed trends in traffic control planning, to fix the speed limits, safe speed limits at curves, location for traffic signs, length of no passing zones, and also it is used in intersection side distance. It is used in before and after studies. It is also used in crash and safety analysis, and it is extremely useful for geometric design elements of a particular section like horizontal curve. Time mean speed is a point measurement, whereas space mean speed is a space measurement. In case of space mean speed, we mark a section of the road which is sufficiently large, of let us say length L, and we measure the time taken by each vehicle to traverse this distance like this. So we measure the time taken by individual vehicle, and then we take average of the time, and this the length of section divided by this average time, that is the space mean speed. So space mean speed, basically the length of the section divided by average time taken by a series of vehicles, or you can say all vehicles which are traversing the length L. Now again we take example, let us say you mark a 1 kilometer section on the highway or on the road, and you measure how much time individual vehicle takes to traverse this 1 kilometer length. Let us say you have three vehicles. The first vehicle takes 60 seconds, second 45 seconds, and third 72 seconds. So we take average of these three, or you calculate what is the speed of this vehicle, that is 60 km per hour, this is speed 80 km per hour, this is speed is 50 km per hour, and then take average of these three speeds, 61 km per hour. That is space mean speed. Alternatively, you can take average of these three times, that is 60 plus 45 plus 72 by 3, 59 seconds, and then you find out what is space mean speed, that is 1 kilometer divided by 59 seconds into 3600, that is 61 km per hour. So space mean speed is measured over a length of the road. And there is a correlation between space mean speed and time mean speed. Space mean speed is always less than time mean speed unless all vehicles are moving at the same speed. So this time mean speed is space mean speed plus variance in space mean speed divided by space mean speed. Or you can say the space mean speed is equal to time mean speed minus variance in space time mean speed divided by time mean speed. Next two speeds are running speed and journeying speed. And these can better be understood through this network. Suppose a vehicle from here, point A, want to go to destination at point B. And there is a signal here and there is a stopping here because it has to take right turn, and there is a complex here where the driver or the occupant of the vehicle may like to do some shopping, and finally it will reach to the point B. So this delay here and then delay here and then shopping time here and then finally reaching to point B. So running speed is the average speed maintained over a particular route while the vehicle is moving. Now this phrase is important here, while the vehicle is moving. So in running speed, when you calculate running speed, you do not include the delays and stopping time. Running speed is total distance divided by running time. Whereas in case of journey speed, it is also called overall speed. It is the effective speed, means you determine the total time spent by the driver from A to B. So journey speed is less than running speed, and that will indicate that the journey follows a stop-go condition with enforced acceleration and deceleration. Total distance upon journey time. The applications of running speed and journey speed are to evaluate the quality of traffic movement along a route, or to determine the location, types and extent of traffic delays to a moving vehicle on a route, and it can also be used for economic evaluation of highway improvement plans. For example, if you want to reduce the congestion on a road by making a flyover, then what will be the impact of flyover on speed, running speed as well as journey speed? That will decide the economics of the flyover. Spot speed measurement can be done by several methods. There are some direct methods where you can use stopwatch or enoscope or pressure contact tubes. These are the methods which are used over a short length, and that is why it is called the spot speed. The spot speed can also be measured through radar speed meter, or it can be through electronic meter, or it can be through photographic method. But when you measure speed over a long distance, over a long section, then it becomes space mean speed. And these are the guidelines given in ITE handbook, that when you have extreme speed below 15 km per hour, the length of the section should not be less than 30 meter, and for above 25 km per hour, it should be at least 90 meter. Stopwatch method. Here you can mark a small section of length L on the road and find out how much time a vehicle will take to traverse this length. So you can note down the start time and the end time. That is from front to front. Now the problem with this method, or you can say disadvantage of this method, is that the readings are influenced by the observer's reaction time, and the parallax will affect the observation of the vehicle position. The accuracy of stopwatch is also important because length is small, so the measured time is also small, and small error in measuring the time will multiply the error in the final speed value. In enoscope method, this problem of parallax is removed. An observer stands here, and this is the enoscope, that is basically a mirror at 45 degree. so that a person standing here can see the vehicle position. Now here also we mark two lines on the road, the small distance, and we find out the time taken by the vehicle from this reference line to this reference line, and then you calculate the speed. So it removes the parallax error, but accuracy of stopwatch remains a issue, and also direction time of the observer. The third method is pressure contact tubes, where these contact tubes or pressure tubes are inserted into the pavement, and the time taken by a vehicle to pass over these two tubes will be recorded. This is used for a longer period of data collection, and storage of large amount of individual vehicle data can be made easily through computers. Radar speed meter method is extensively used by traffic police for speed enforcement. It works on Doppler's effect. This is the radar gun. It is focused or targeted to a vehicle, and will simply show the vehicles in kilometer, the speed in kilometer per hour. Electronic meter method requires use of pneumatic tube and air switch or electric contact stripes as detectors, and on actuation, the current in milliamperes is allowed to accumulate in a condenser for a period of 2 electric pulses from the switches on the road. This meter is calibrated to read the speed in kilometer per hour. The photographic method is also used to determine the speed of vehicle either through time-lapse photography or maybe a normal video camera. In this case also, we mark a small trap length on the road and find out the time taken by a vehicle to cover the trap length. In time-lapse photography, the photographs are taken at fixed interval of time using a special camera, and then we find out how the position of the vehicle has moved from one exposure to another exposure. There are now programs available with the use of artificial intelligence which can find out or which can demonstrate the speed of individual vehicle in real-time situation. And these speeds can be stored in a computer which can further be analyzed at a later stage. The speed data representation. Speed data collected in field can be represented either in the form of a frequency table like this, that based on the minimum and maximum speed, you create a class interval of, let us say, 2 km per hour or maybe 5 km per hour, depending upon the number of data points and minimum and maximum range. And then for each range, what is the frequency of the vehicle observed? This is called frequency distribution table. You can express in actual number, or you can take the percentage of total frequency. Total frequency here is 299. That means 299 vehicles were observed. And this is the cumulative frequency. It can be in the form of a frequency distribution curve, or you can say simply probability density function, which looks like this. On y-axis you have frequency, that is this table, this column, and on x-axis you have the speed. This will give you the distribution of speed, and it will also give what is the speed at which the maximum number of vehicles are moving. Now this can further be changed to cumulative frequency distribution curve of this type, which is generally of S shape. And this curve is extremely useful to determine the 15th percentile speed, 85th percentile speed, 98th percentile speed, and also the 50th percentile speed. Now 15th percentile speed, a speed that is exceeded by 85% of samples. Now 15th percentile speed is the speed that will be exceeded by 85% of the drivers. And this speed is generally used for signal timings for pedestrians, and this speed is also used to determine the lower speed limit on major highways. The vehicles traveling below this speed will cause interference, and that can also result in accidents. Now 85th percentile speed is the speed at which 85% of the drivers will be moving. or you can say a speed that is less than 50% of a set of field measured speed. The speed at or below which 85% of the drivers will be traveling. And this speed is generally used as posted speed limit. 98th percentile speed is used as design speed. Another type of speed is free flow speed. The free flow speed theoretically is the speed when there is no other vehicle, a single vehicle moving on the road. And I explained this free flow speed when I was discussing level of service concept of two-lane and multi-lane highways. The theoretical speed of traffic when density is 0, and the average speed of the vehicles over an urban street segment without signalized intersections under conditions of low volume. Now, low volume here is important. The free flow speed represents when the driver has full freedom to operate. The driver has freedom to choose his or her own speed. And to measure free flow speed, the highway capacity manual of US has given some conditions that a vehicle will be considered in free flow situation when the headway is 8 seconds and tailway is 5 seconds. For Indian conditions, we generally take gap rather than headway because the length of different vehicles is different. Now, other speeds which are also used in traffic engineering but not so common, the crawl speed, that is the maximum sustained speed that can be maintained by a specified type of vehicle on a constant upgrade of a given percent. The critical speed at which the capacity occurs for a facility. Travel speed is the average speed of traffic stream computed as the length of the highway divided by the average travel time of the vehicles traversing the segment. Wave speed, at the speed at which a shock wave travels upstream or downstream through traffic. Statutory speed, that is the numerical speed limits established by the state law that applies to various class or categories of the roads in the absence of posted speed limit. A speed zone is the speed limit established on the basis of engineering study for a particular section of road for which a statutory speed limit is not appropriate. Advisory speed is recommended speed where there is a need to reduce speed below the speed limit due to specific road conditions. And operating speed is defined as the speed for the facility for prevailing conditions. This speed becomes free flow speed at low flows, and it is also taken as 85th percentile of free flow speed. Thank you very much for watching this video. You can write your comments in the comment box.